Hello, welcome back to this channel. In today's tutorial, we are going to look at improper integrals. What are improper integrals? In calculus, when we say improper integrals, then we mean they are type of definite integrals that deals with infinite limits. Either way, one or both of the limits of the integration are infinite, and these functions are being integrated has a discontinuity within the interval of integration. Now let's look at ways in which improper integrals are written. So when you look at this particular question, with this particular first one, we see that one of the limits is infinite, in this case, the upper limit. So we can also have an improper integral where the lower limit is also infinite. Or in other way too, we can have both of the limits of the integration being infinite. So that is what improper integrals are. So before you can solve or integrate improper integrals, because improper integrals do not have the standard definition of a definite integral, then to evaluate improper integrals, then we use the limits to approach the infinity or the discontinuous point. That's why you see the limit here. So because they are not standard definite integral, then we need to introduce limits as one of the upper or the lower limits. One of the limits approaches infinity. So in this particular question, if you want to integrate an improper integral, then we introduce limit or we use limits to approach the infinite or the discontinuous point. Okay, so now a case where we have both of the upper and the lower limits to be infinite. Then here at the limit part here, we have b as it approaches positive infinity and a as it approaches negative infinity. So after integrating the function, then you substitute the values of the upper and the lower limits into your final result. Now let's look at the question here. In this question, we are to evaluate the function 1 on root x dx where the upper limit infinity or infinite and then the lower limit as 1. So we know that 1 on root x is the same as 1 on x exponent half. Now 1 on x exponent half can also be written as x exponent negative 1 on 2. So if you are to integrate this one, as usual, we add 1, then we divide by 1 on 2, negative 1 on 2 plus 1. So in this case, negative 1 on 2 plus 1 gives us gives us 1 on 2. So the same thing at the bottom here. But do not forget that the coefficient of x is 1. So here we have 1 on 2, which is equal to 1 on 1 divided by 1 on 2. It is the same as 1 times 2 on 1, and that gives us 2. So here we can have 2 exponent 1 on 2, which is equal to 2 root x, and that's why we have it here. So after getting the result, then we substitute the upper and the lower limit into it. So we are going to have 2 root b minus 2 root 1. And root of 1 is equal to 1. So 2 times 1 gives us 2. So here we are going to have 2 root infinity minus 2. So the final result is, punch this one on your calculator, you see that we have infinity. Oh yes, so that's the result for evaluating this particular limit. Now let's look at a different question. We are to evaluate 1 on x squared plus 1 dx. Do not forget that 1 on x squared plus 1 is equal to tan inverse of x. So the result for integrating the function 1 on x squared plus 1 is the same as tan inverse of x. And that's what we have here. Now the limit is at the infinity symbol is at the upper limit. So the limit as b approaches infinity. Then we substitute the values of the upper and the lower limits into our result. So substituting b here, we have tan inverse of b minus tan inverse of 0. And tan inverse of 0 is 0. So 0 minus this tan inverse of b minus 0 is the same as tan inverse of b. So after getting to this place, after getting to this place, then we need to substitute the infinity here into our result. So we are going to have tan inverse of infinity, and that gives us pi on 2, which is the same as 180 divided by 2, and that is 90. Great. Now let's look at a different question that involves trig functions. In this particular question, we are to integrate x sine x dx, which is a trig function where we have the upper limit as 0 and the lower limit as negative infinity. For us to integrate this particular function, we can use the strategy that is integration by parts to integrate this particular function. And the formula for integration by part is given as integral u dv equals uv minus integral v du. So in this function, now let's choose our u to be equal to x and then our dv to be equal to sine x. Great. So here, if we integrate, if we differentiate u with respect to x, we are going to have du on dx, which is equal to 1. And therefore, du is equal to dx by cross multiplying dx by 1. Now here, let's integrate our dv. So to get our x, so we are going to get our v. So integrate this side, you do the same thing for the other side. So here, our v is equal to integral of sine x is negative cos x. Great. Now let's substitute the result that we have here into the formula. So now our u is what? Our u is x, and then our dv is sine x. Great. Set is equal to our u is x, and then our v, which after integrating we got negative cos x. Great. Minus, so minus integral v, our v is negative cos x, so negative cos x, and then our du is equal to our dx, so which is equal to, right, so this one is equal to, now x times negative cos x is negative x cos x, negative x cos x. Please do not be tempted to write cos squared x. This is x times negative cos x. This is negative x cos x minus. So we have to integrate this one again. So integral of negative x is what? Um, is what? Sine negative sine x. Great. So here we are going to have negative x cos x, and negative times negative is positive. So we are going to have positive sine x here. And that is what we have here. Great. So after getting the result, then we need to substitute the upper and the lower limits into our final result, in which we have negative 0 cos 0 plus sine 0. Great. So the whole of this thing will tend to 0. Then we substitute this one too. So this is negative a cos a plus sine a. So here, this negative will affect the entire thing. So negative times negative will give us positive. We're going to have a cos a. The negative times positive give us negative. So we are going to have sine a2 here. And that is what we have here. Do not forget that sine a and cos a oscillate between positive and negative. So after substituting the limit as a approaches negative infinity, our final answer is going to be negative infinity. Thank you, and don't forget to subscribe to our channel.